with that, let's get right to our expert presenter, and that's Mr. Dan Arthur. Mr. Arthur has 40 years of experience in the energy and environmental industries. As a registered professional petroleum engineer, Mr. Arthur has led more than 2,000 stray gas migration investigations involving characterization and measurement of gas migration and emissions from oil and gas wells, including idle and orphan wells. As a former staff member with the US EPA, Mr. Arthur served as an expert for EPA in the 1980s, served on the National Mechanical Integrity Test Work Group, and developed Region 5's well plugging guidance. He has led research on best practices and other issues for the US Department of Energy's National Technology Lab, led orphan well restorations, including DOE-funded research with the Kansas Corporation Commission, as well as many other restoration projects involving soil cleanup and associated remedial activities. Mr. Arthur also served as a subgroup leader for the National Petroleum Council study, served as a consulting or testifying expert in more than 2,500 dockets and or cases, and has been involved in countless well plugging and abandonments, including the restoration efforts. We're really happy that, Mr. Arthur is with us. Some of you may have heard him speak. He's in demand as a presenter on this topic. We're glad to have you, Dan, and thank you for taking your time to be with us and sharing this expertise with our audience. With that, Dan, I'm going to turn it over to you. Dana, we'll get your slides up, and at the end, if there are questions we'd like, all you participants, if you have questions that come up, would you please enter them down below in the Q&A pod, and we'll attempt to get to them at the end of Dan's presentation. With that, Dan, I'm going to turn it over to you. Welcome and thank you.
Dan, you're on mute.
Dan, Dan, you're on mute.
There we go. Can you hear me now?
Good.
Yes.
Okay. Well, thanks for having me. I'm glad there's a number of people here from a lot of state agencies. Hopefully some of you I've had the pleasure to meet some of you, perhaps. I don't know. Just saw lots of people, haven't seen the list yet, but nonetheless, I'm excited about this today. I've tried to include a number of pictures and graphics that I'm sure many of you can relate to. I saw that on the comments there were a number of people from Pennsylvania and New York and Ohio and Oklahoma and all over. So maybe some of these will be of interest and so forth. So I'll also say that you know, you guys are dealing with this every day in a variety of ways. So I certainly don't want to put myself above anybody that's on this call. You guys probably know more about some of this stuff than I do, especially in your areas. But hopefully we can go through some things that everybody will find interesting. So with that said, so just as an overview, here's what we're going to talk about. I'm sure that that many of you've seen pictures like this. You know, I'm big into history and understanding how things were done in the past. We're going to give a little example of the Turkey Mountain urban wilderness here in Tulsa, Oklahoma, as an example as we go forward, and just some of the things that can happen and that we need to be thinking about as we work on this stuff. So first, these general considerations, and this map in the upper left, I think is interesting. So I'm going to show another map that EDF put together with help of a university, but this is one that is simply inactive wells, kind of in the mid-continent area. So it's not just orphan wells, but as you could see, and I'm sure you know everybody can relate to this very differently, but when you look at here where I'm I'm from Tulsa, Oklahoma, and certainly been in a lot of places, but when you look at the number of wells that are inactive, that probably are going to need plugging, it's a bit overwhelming, and trying to get this point across to everybody in the amount of time that this is going to take. You know, the former Montana Board of Oil and Gas Conservation Director Jim Halverson was interviewed and said, you know, these wells took, you know, 150 years to drill. You know, we can't expect to get them all addressed or plugged in, you know, in a couple of weeks. This is going to take a while. So we're in this for the long haul. So one of the things that I know the Interstate Oil and Gas Compact Commission, DOE, all the states have really been looking at is trying to understand priorities. There's a number of approaches to this in looking at priorities, but one of the things that I've really tried to make a point to people is that, you know, the current federal funding that's going on has a focus on eliminating or at least reducing methane emissions from orphan wells or open wells or non-producing wells or maybe improperly plugged wells. But that's certainly the focus. So this is I think a fundamental change in what we're looking at, and everybody may not agree, but in my experience over the years in a lot of different areas, we looked at trying to protect, you know, freshwater USCWs and did things very basically. But as I've seen through doing a whole bunch of stray gas migration investigations in areas like Ohio and especially Pennsylvania, you know, just putting some cement in the hole doesn't always work real well. So we've got to really, I think, look at that as we go forward. But you know, and here's another thing I'd say that we may not all agree on, but as I've looked at the numbers, the number of documented orphan wells in the country, you know, is, you know, a couple 100,000. But you know, where I've seen this and just, you know, being involved in developing the risk-based data management system with the Groundwater Protection Council and being to a lot of states and studying history and looking at so many maps, you know, I'm estimating that, and I've seen similar estimates of about 2 to 2.5 million orphan wells, maybe 500,000 leaking plugged wells, maybe another 1 million to 1.5 million non-producing idle wells. So this is a big issue. It's going to be with us for a while. And moreover, as we'll see, and I'm sure all of you have seen, but these wells can present an environmental threat or a risk. Not all of them are the same. So you have high emitters, some that really aren't emitting or are too much of a problem, but are a bother. But you know, as an expert and that does a lot of expert witness testimony for both states, industry, you know, various groups. I've seen fatalities at orphan well or historic well plugging projects. I've seen these wells result in fires and explosions of homes, of buildings. So these can be some real issues, and moreover, you know, a lot of times there's a lot of equipment and other things left out there, soil contamination from brine, from oil, from other products, groundwater issues. So there's a lot of considerations that need to be done. So really understanding that history and so forth is just critical for us to, I think, move forward successfully. So I saw that there was some New York DEC folks on the webinar. So this is an example from there that I really appreciated it because this is a well in New York, was you know, let's say leaking brine and gas. It was kind of a party spot, so people would go catch it on fire and drink beers and talk to their buddies, and nonetheless, it didn't look real great. and it got cleaned up. But using a lot of tools in the toolbox there, I think the state did a great job at managing this. But you know, some of the things that we can come across with these orphan wells and orphan well plugging, and the things that you really got to look at are huge. And stopping stray gas and some of these emissions of fluids and gas is a huge issue. So now, you know, you kind of go into some of those general things, and we look at you know, locating these wells, and this can be a hoot. You know, so, you know, if you look at, they've got pictures of Kiefer, Oklahoma, you know, wells all over the place. That this bottom center picture was a well that I plugged in the 1980s in the Wabash River between Indiana and Illinois. The bottom right there is, I believe that's a well up in Leon County, Kansas. So you can run into just a variety of different things, but finding these things can be a booger. So if you remember the picture I had showing you idle wells, this is a picture that EDF put together showing 81,000 wells, and the number of orphan wells has gone up here recently. But trying to understand and find these wells is a challenge. So, you know, there's a lot of issues that can come into play here in Oklahoma. I saw there were some folks from the Oklahoma Corporation Commission, but we have a lot of man-made lakes here. And one of the issues that occurred when the U.S. Army Corps of Engineers was building dams and flooding lakes is we have several of the lakes here in Oklahoma that have unplugged orphan wells below the water line. One in particular, Lake Skiatook, has 27,000 unplugged orphan wells below the water line. So when you start thinking about numbers like that, it's a little overwhelming. So understanding those geologic settings and the history of the various areas, it can be huge. And moreover, you know, we're talking about today in orphan well plugging, trying to plug these wells permanently, and historically that varied a lot. You know, so you know, in Osage County, Oklahoma, in the very early 1900s, say 1900 to 1910, many wells were plugged with brine because they were produced, they were under low pressure, and they just put brine in the hole. And maybe they put a wooden plug at the top, but oftentimes they didn't even do that. And so that those issues can vary widely. So we're going to go through and talk about some of those. But as we start looking at these are other examples from state of New York and ODNR on some of their magnetometers. So there's certainly physical searches that can be done with magnetometers, gas detectors, infrared imagery. We've used drones with cameras and stuff just to look at that. But on the other hand, we've had to, and especially in places like New York and Pennsylvania, and even northern Michigan, we've had to go through historical societies and newspapers even, trying to find information on wells, because the wells didn't have any casing, but they're present. And if you think about this, and I've given several of these talks, and you guys up in the Northeast, I'm sure know this, but I'll ask people, you know, what is the deepest cable to a well ever drilled? And typically the answers I get are 500 to 1,000 feet. And these are by industry people typically. And for the guys in New York, the deepest cable to a well drilled was drilled in the state of New York to about 10,000 feet. And many of those old cable to a wells had the casing removed, so they're tough to find, and having to dig in through published documents, historic records, old maps, even talking to locals in the community to understand where those might be has been critical. So the magnetometers can be, for instance, in this can be massively helpful, but they are not going to help you find everything. So like I said, some of these historic maps, this is, a couple of examples from here in Oklahoma, but looking at those records, unpublished maps. I'm a member of the Petroleum Historical Institute and a couple other historical societies for relative to oil and gas, and they can be, just a great help for trying to find some of these old wells. So as you do this, just keep in mind there's a lot of historical records. Even in a lot of the state regulatory agencies, they'll have the Railroad Commission has got great data. You go over to Ohio, to the Ohio Geological Survey, you can get some of the old maps. One of the first state geologists was a guy named Dr. Pepper, and he assigned pepper numbers to a lot of these old wells. And hopefully those will all get, as part of this, get digitized so we have those on maps, but it's a challenge. So we've also talked a little bit about the infrared imaging. One of the issues with this, we've had a lot of success at finding wells, finding leaks, finding where things are as far as issues. But those OGI cameras are limited. So one, they don't actually tell you a volume. They can give you an idea of a volume. So we've done some things where we've measured gas from wells and then tried to compare those to imagery to gain a general volumetric estimate, but they're certainly not perfect for that. But what we have also done is we've seen areas like Burke Burnett, Texas, where we found a lot of emissions coming from areas of old production where there wasn't necessarily wells, but there was wells that were getting into groundwater, and we were seeing seeps at the surface that way. So it was a good thing to be able to go there, plug wells, and see that be eliminated, which was really nice. So the other thing is just kind of the planning and managing risks, and I'm gonna take a quick second here just to say something, is that this is a really broad issue. It takes a multidisciplinary team to address. We're going through this in 30 minutes, so I apologize for not getting into excruciating detail here. So there's a lot here. So this is really an overview of everything. So as we look at these risks, one of the things that I think is certainly interesting is we start looking at the historic well construction that's been out there. It's changed tremendously. So these casings that you see here in this slide is stovepipe casing. Back in the day, in the early 1900s, out on the West Coast, it was called California casing, and was it was the thing. So 16-inch casing might be 80-90 pounds per foot. So it's not like the stovepipe in your house. But what they had to do, because they didn't have a lot of the perforating tools and so forth that we have today, is that they would manually perforate the casings before they put them in the well. So it's just an interesting thing to think about. But understanding what that is and what that history is in some of these wells is a big deal. And if you're trying to re-enter some of these old wells, realizing that when they shot casing off, oftentimes they didn't do it with the way we do now. They did it with with explosives. So just a little different thing, and it can make access into those old well bores tough. So some of the critical risks, and we've already been talking about this a little bit, but methane is highly flammable. It's a big deal. I would say that on some of the litigation stuff that I've done, a couple of them have been with welders, where there's been explosions at an old well site, because oftentimes there's a need to weld new wellheads or better pipe or something on there so that you can get access. But oftentimes, or sometimes anyway, people don't really think about making sure that what the gas level is and that it's not going to cause an explosion and wind up burning somebody. So, I just say make safety a major priority. But we see hazards existing and at the surface, from buildings, from houses, from apartment complexes. There's a lot of areas where there's been a lot of construction, over the top of old wells. In Cleveland, Ohio, when they built the Rock and Roll Hall of Fame, you Ohio guys probably at least know this. I think there was 12 or 18 old unconventional wells that had to be plugged that were actually in the lake. So kind of a big deal, but they can come up anywhere. So really looking at that is huge. So I'm going to give another example of that a little later in the presentation. But what I've seen is a failure to understand, some of these risks, especially historically, has resulted in some major issues. Because we used to build wells vastly different 100 years ago, 150 years ago than we do today, and keeping, learning that, keeping that in mind, understanding it is crucial. And here's, this is, I love some of these old documents, but this is, the picture upper right is, well drilling methods from 1911. So you could see a little different, but it's just an example of how different, some of this can be. So if you look at just some of the very basic things, surface casings were largely used to prevent fresh water or even brackish saline water from entering oil and gas reservoirs. They wanted to protect that oil. That's what had value. With cable tool holes, a lot of casings were intentionally not cemented because they knew, there was gas, intermediate gas that maybe wasn't what they were really after. They were after the oil. And so they wanted that gas to vent, maybe so it wouldn't get in people's water wells and so forth. And sometimes, a lot of times, casings were removed or not cemented because they wanted to be able to get the casing out and reuse it if it was a dry hole. But if they produced a well for a while and wanted to reuse that later on, they didn't want to cement it in the hole so that they couldn't access it because that cost more money. So the guys, I'd say, especially in the Northeast, are probably very aware of the whole, stray gas or gas migration issues. It's been an issue in places like Pennsylvania and New York and Ohio and West Virginia for a long time. A lot of water wells have had gas in them for, many times. There's gas vents on water wells to allow that where there's just naturally occurring gas. But as we start looking at plugging, the idea of stray gas mitigation is more significant, and I hope that we can take some of those lessons learned from the kind of the gas migration investigation work and remedial activities as part of those, and testing and logging and so forth, and trying to understand that is huge. And I see a comment, stray gas issue in Alberta in BC is a big deal, but that's I think Canada did, and Alberta especially did work on some of the plugged wells that kind of gets to my point, and showing people are going and plugging wells, but they were plugging them really to keep liquids from moving, say, into an underground source of drinking water, to keep producing zones isolated. But now we've got to really think about the whole eliminating the potential migration of gas. So that's where a lot of the federal money is coming from and for. So we've got to really think about that. So, and I keep preaching a little bit on history here, but I've done so many of these that just understanding history is so critical. So if you just look at, we talked a little bit about the practices, but API wasn't around until 1919. Most of what you see, a lot of the states really didn't have much in the way of regulations on some of this stuff until the 1930s. Industry practices varied substantially. If you look at, the cementing process, document from back in the day, or even some of the well construction or well plugging processes that were put together in the early 1900s. If you looked at those now, you would not believe it. But if you fail to have that appreciation for what was done then, your plugging jobs are going to be tough. So in addition to those regulations, one of the things a lot of people fail to understand, I was doing some work here recently, and if you think about this, the Safe Drinking Water Act amendments and the UIC program came around about 1980, which defined a USCW. There was, state regulators that were, states really use different terminology. I remember when I was at EPA in the 1980s, this is maybe 85 or 6, and the state of Texas was using base freshwater at 3,000 milligrams per liter TDS, and their governor actually sent a letter to EPA. I still remember it saying that if EPA was going to force them to protect down to 10,000 milligrams per liter TDS, they were going to secede from the union. So, but that was, it's kind of a bummer getting old, but that was the 1980s. So things have changed a lot. But before then, people don't realize it. And I've seen other experts when asked, when did this come into play? Was it there in 1900, 1930, 1950? And a lot of people don't know because they just haven't looked at this, and it wasn't. So when you start looking at how wells were constructed to protect fresh water, usable quality water, or irrigation water, or whatever that might be, it was vastly different than what we do today. Just as a side, these pictures on the right are this well from in the Wabash River. We've seen this, I've seen it there, but I've seen this a lot in Oklahoma as well, where our rivers change and we lose wells. So what you see in the rivers is there's actually a number of wells that have been lost there. I wanted to get a picture of some of the stuff around even the Glenpool oil field and Tulsa, where we had a lot of drilling within the rivers, and I'm sure that's occurred in many places. So, rivers, lakes, all that. I mean, these can be, a challenge when you start looking at, trying to manage plugging operations because you're limited. I want to throw a shout out to both the Interstate Oil and Gas Compact Commission and the Groundwater Protection Council. These are, IOGCC has been, doing stuff with orphan and idle wells for a while, multiple publications, and looking at some of this. I think that both these two organizations can be really great at working with the states at coming up with new best practices. There's money in the federal funding that is available now that is geared towards expanding, improving regulations relative to the plugging of idle and orphan wells. So, that's something I think that these two organizations will be involved in. And if you are planning to go to either one of these, their conferences this fall, just, say hi. I'm going to be at both of them. So anyway, these are, I just been working with both IOGCC and GWPC for a lot of years, and they provide some great arenas to be able to go through some of these things and really help the states in a big way. So the other thing, and I'm going to go through a little detailed here, just really just for example, but this is a handbook of the petroleum industry, 1922. And if you think 1922, 100 years ago, and the technology of the day, so the kind of the best practices, the standard industry practices, the things we're taught to do, had books and technical books showing that you need to use wooden plugs, you need to and just how you place cement, lead plugs, other things along that route. They would also use things that were more like concrete as opposed to cement. Some of the cements that were used were very different than today. So another thing to keep in mind as you get into plugging, it's the technology that we're doing has improved dramatically. And even now we got new K&L grades of cement with limestone in them. So there's a lot to think about, but again, that history is a big deal. So if we look at, the National Petroleum Council has also done stuff on this, more recently, 2011, looking at well abandonment standards and practices, referencing some of these things. They could be good references for you. Both NPC, API, there's a number of resources out there that I think could help. I will say, and I wanted to pull this one in here because it's got, modern cement additives that can help with performance and all that, but you can also have additives in the cement relative to eliminating or reducing gas migration. I'm going to give an example of one of those, a different kind of a specialty cement here in just a second, but these are good things. So we've got some Ohio examples over here, and like I said, this you can have these wells around and people don't think about them, but they're huge. So those those potential hazards are a big deal. And I will say that just on the identifying and finding wells, there's a number of people, and I hope from a state perspective that you guys can appreciate this, but there's a number of landowners that I know that don't want to say anything about wells on their property because there's old equipment and so forth. And sure, there's some things that may have value, but there's also historical value in place as well. And that's one of the things that we try to do as we're doing these. But and I would also say we've seen multiple cases, and this is just one example where we've had gas storage sites come in areas from California to Pennsylvania and elsewhere near old wells that ultimately cause problems. So we're trying to run through this, so let's keep going here. But DOE awarded a bunch of money. Registered contractors, I would say we're very short in having sufficiency here. I'll tell you that we're working with several and trying to improve that. But what you see is that all these wells take a lot of effort. If we're going to plug the wells, if we're going to do those things, it's a handful, and I'm sure that you guys can appreciate that. Some of the considerations as we continue looking here, understanding the geology, understanding the rock, the things that were used, the well files, and all this. This is an example from Montana with my late friend Tom Richmond and Jim Halverson, who just retired. But the state offices can really have a plethora of information. The problem is it takes sometimes a whole lot of effort digging through paper files that aren't in electronic form, aren't in a database, but they can be a huge help. So some of that research is a big deal. And I'll tell you from our perspective, what we try to do is we'll have like techs help us with that. We've done, some things with students where, they'll come and do an internship or something like that and have them digging through a whole bunch of records. So there's multiple ways to do that, and that aren't, having a 30 or 20-year experience engineer geologist having to do all that. But there's a lot of examples out there. This is from a 1992 API document example. So there's certainly examples out there. I will tell you that if you look at some of these documents today, they're outdated and need help. So they certainly, a lot of the things within them still work, but when we start looking at gas and a variety of issues, it's a challenge. I'll tell you another thing just from well plugging that we've seen, especially in the mid-continent, is that because the idea of induced seismicity, people are injecting at shallower depths, and sometimes some of the wells there maybe aren't plugged in an appropriate way, or there's records that are showing it's plugged, but the plugs maybe weren't as effective on some of these older wells, and they've been problems. So you get things like purges. So lots to just really be thinking about. So this is an example from the same document, but as you look at just some of the basic stuff that I'm sure folks on this call have looked at, got minimum plug lengths of 100 feet. That's what we used at EPA, and so forth. But I'll tell you, we were doing some stuff with back when Rick Simmers was still with the Ohio DNR, and trying to set plugs and keep gas from coming through. And we were working with Schlumberger, and I don't know, I think we set 20 different plugs right on top of another, and they just kept, each time you wouldn't stop the gas. So you've got to really think about that when you're planning your materials and your plugging process. So the BLM recently came out with a couple of solicitations for orphan well plugging on federal lands, included site cleanup and so forth. The photo on the right is on this slide, and the next one is going to be some examples. So they gave an example on the left of a well, and on the right would be at least a potential plugging option for that well based on BLM standards. So so one of the things I'd say that we want to look at as we go forward is that maybe BLM or states will have particular standards on plugging, but as we look through today, I'm not sure that there's not other things that we may also want to look at, as I've tried to preach on maybe a little bit too much here. But here's another one. The BLM split the country into 4 different zones and gave 4 different wells. One in West Virginia, New Mexico, North Dakota, California, based on particular things. This is just another example of the well on the right was the example they gave. The well on the left is the well they gave, or the condition, and the well on the right would be a proposed plugging option for that particular well. Now, there's several of these sorts of things out here, but one that I've been impressed with and have seen used, I would say not with 100% effectiveness, but this was a product that was used from really kind of developed through DOE research. So DOE funded initially. So it's a biomineralization technology. Company BioSqueeze is utilizing this. So it's not like you're not going to go plug an entire well with BioSqueeze, but you can use it to address a variety of things on wells that are an issue, like microannuluses. So this has got a small enough material size that it can actually get into a microannulus, which is huge. So from that perspective, I just say, if you haven't looked at this, or if you want some information, you can, hit me up and I can connect you with the BioSqueeze guys, or send you. I've got a couple of technical papers from them too. So I think you'll get my contact information at the end. So all right, so we're getting down to the end here. I'm trying to hurry. So this is lovely Tulsa, Oklahoma, and in Tulsa we have this Turkey Mountain urban wilderness area, and it's a go-to place here for hikers and bikers and all those things. It's very well loved, and it's also a historic oil field. So if we look at where this is, we've got where Arkansas River here. There was actually wells drilled in the Arkansas River, with this, but through this area, it's a very green area. Lots of stuff happening in it, kind of in almost in the middle of what's happening in Tulsa. And if we look at these photos on the right, without the pretty picture, you guys can imagine what all those red dots are. And so when Turkey Mountain was put together, this friend of mine, Ray Sorensen, he's a history geologist. He did, and some other folks did a lot of work with the Tulsa Geological Society and the Petroleum Historical Institute on finding these wells so that the wells in Turkey Mountain in that wilderness area could be plugged. Many of the wells there don't have casings. They're within, say, 1,000, 2,000 feet. They're not as old as maybe some of them, say 1910s, 1920s, but can be an issue. I'll also say all the wells that you see in this picture on the bottom were not plugged. The wells in the wilderness area were plugged. And one of the things that I've seen recently is here in Tulsa, we're getting a new REI. I've been trying to reach REI and haven't had any luck yet. But over the property, which is across the street from the wilderness area that they're planning on putting the new REI, there's a number of Orphan unplugged wells from the same era. So I'm hoping to be able to contact them in advance of them putting a building there so we don't have problems, but it's an example of what can happen. It just, I don't know if there's any Oklahoma guys on the call that recall this, but it was done a while back. So just to kind of close this out, some of the takeaways, we got $4.7 billion of money with a focus on methane emission reduction. The solutions I've been asked by different professional societies and so forth is like, hey, this is an engineering deal. Why are you giving presentations to, say, the AAPG or some geological society? And what I tell people is it needs a multidisciplinary approach, because you need engineers, you need geologists, you need environmental folks, you need people that can look at gas, quantify gas emissions, they're good at using drones. You have to have, to be a drone pilot and to do this kind of work, you have to have a license and so forth. And I mean, so you need GIS people and all sorts of things. So just with that, I would just, this is not just a one background does everything. So like I mentioned, the funding includes, development expansion of regs. I suspect that that's already going on, and that folks like IOGCC and GWPC can help with that. Best practices training is certainly needed. This is great, but at the same time right now, yesterday I spoke at a SPE International Orphan Well Plugging Conference that's goes from yesterday through tomorrow. It's a virtual webinar type conference, but it's got some people from all over the world, and it gives you that opportunity to step out of the box and see stuff that's not just North America, but is Albania and Europe and Africa and so forth. So that's good. And I'll put a plug in that February 21st and 2nd in Oklahoma City, AAPG is putting on an in-person orphan well plugging workshop. I'm the technical chair of that, but hopefully, if any of you guys are interested, maybe that's something that would be possible for you to attend. And lastly, I'll say, one of the other things I've been trying to do is coordinate with some of the museums around the country and history collections. You can't really see it that well in this picture in the bottom right, but that's an old wooden casing that was extracted from a well. So there's a lot of the stuff that there's historical value, and a lot of people don't want to see that just destroyed. So here's my contact information. If any of you guys would like to, I'm happy to happy to connect and communicate and so forth. This is an area I'm passionate about and working on and have been for some time. So with that, John, I'm good.
That's great. Dan, thank you for the presentation. Wow, what a lot of information. And I particularly love the historical perspective that you bring into that and show, kind of where we came from to be what we've got today, and some of the solutions that are possibly out there. Thanks again. And there are a couple questions here, Dan. I don't know if you can see them. I'm glad to read them just in case for everybody's benefit here. One looks a little Pennsylvania centric, and I'm not sure there's a solid answer, but Dan, I'll throw it out to you. And Steve says, with federal appropriations targeting the capping of orphan wells in Pennsylvania, or are orphan wells on private land subject to the appropriations?
So I see Steve had two, and I've got these questions here, but
okay.
Orphan wells on private so there's a couple of different things. So the BLM appropriation of what they did, that's federal lands, kind of federal and Indian lands. The money that at the same time Department of Interior, Department of Energy have provided states about $25 million, and that looks like that may be an annual thing here, at least for a little while, and that could be applicable to orphan wells, plugging orphan wells on private land. So there's really multiple different things. So there's some BIA stuff, some BLM stuff, and then the money that's going to states. And I see the one at the bottom, minimum compressive strength for plugging, and I'd say that's a tough question because it really depends on the specific thing you're doing. So like on wells where we're trying to stop gas, sometimes we'll use a resin or say a microfine cement or something else like that. Those have lower compressive strengths, but you can use a heavier weight cement with a better compressive strength on there. I'll tell you that in areas like the Northeast, so I don't know just where Everett is at, but what we've seen there is we've had to adjust cement blends because in like especially kind of say eastern Pennsylvania, the underground temperature stays a lot cooler than you might anticipate, and within that, if you don't account for that, the cement may not set up properly, and you may get a far lesser compressive strength than you were anticipating. So you really got to look at compressive strength and some of those other things on a not even a well by well, but each issue that you're looking at within an individual well plugging. And I see another one, how many of the unplugged wells alongside the Arkansas River were field inspected and found. And I don't know that that'd be a question for Ray Sorensen. I know that he did go out and identify all of the wells in the wilderness area, but I don't know about the other ones. I know that they did a lot of work in historical records and all that to find that. I've got, Ray is retired. I have all of his documents on that. So, if you are curious, I sure wouldn't mind making a copy of everything we have. But we do have well files. I just don't know. I don't know how much of that was field verified.
Okay, thanks, Dan. And as a comment, we still have a few minutes, and we've got a lot of people still hanging on. So if you have a question for Dan, please would you drop it into the chat pod, or excuse me, into the Q&A pod. And I noticed that a couple people raised their hands. From a technical standpoint, I don't know as we can get audio from you. So if you have a question that you'd like to pose, please would you just quickly get it into the Q&A pod before we get to the top of the hour here. And with that, someone's also asked about the recording. For all of you that have participated here today, in a short period of time, you will get an email with the link to this recorded session of Dan's, and please review it and share it with your friends. Dan, I was interested in the slide you had with the number of contractors I think you gave examples of maybe 4 states. I was surprised at the number. Again, I'm sitting in Pennsylvania. I was surprised at the number that Pennsylvania had, and wondered if just in general, with the dollars that are coming into states, whether you've seen a dramatic increase in people that are trying to gear up to get into the business.
So one of the things that I'm doing tomorrow is there's a plugging contractor here in Tulsa that is growing. They're buying rigs and so forth. I'm going over there tomorrow to do a training for their folks, but it's I'd say a very significantly growing area.
Okay, thanks.
But I'll tell you at the same time, John, is one of the challenges is finding people. And what's however you think about it, we don't train our kids here like we used to, and in school and so forth. So so if you don't speak Spanish and you run a plugging company, you are in trouble. And that's not to say that it's that's that way everywhere, but we really have got a lot of work to try to get people trained and so forth out there. So
yeah, thank you for that. And Dan, I'd ask you to mention the date for the Oklahoma City training. There have been a couple questions about that.
Yes, it's February 21st and 2nd. It's going to be at the Ham Center. If you look on my LinkedIn page or AAPG's, there's a website out for that now. And Susan Nash at AAPG is the person to contact. So, but it's in Oklahoma City, February 21st and 2nd, and it's in person. So we tried to make a big deal of that, to not have it as a webinar, because we wanted people to be able to talk and visit about these things. So so far I think it's going to be very well attended.